Hey guys, and welcome back to another video of Sparkplug. So in this video tutorial I will be showing you how to make parametric design in Fusion 360. So just to show you an example, I have in here a bolt design. Of course all the dimension has been assumed. Again I am saying that all the assumed dimension has been assumed, and this tutorial is just to show you the basics of parametric design in Fusion 360. For those of you who don't know what parametric design is, basically parametric designs consist of all the inputs that is necessary to make a particular bolt. For example, here I have a bolt. Let's suppose that here I have a bolt of M10 type, and the length is going to be 200 mm. So what if I need a M5 bolt of 15 mm length? So I don't need to remake and all. Don't have to design it again and again. I just need to design a one bolt with all the parameters, and if I just change some of them, the whole design will get updated automatically. Suppose that I need to, for example, let's suppose that the length is X. I don't know, the length is current. So what if I just want this bolt to be made shorter, but without changing any design? So what I'm going to do is go to assemble, go to modify. I will go to modify, and here's an option for change parameters. I will just show you, wait a few minutes and I will show you the each and every step how to make this bolt in Fusion 360. So here you can say see the bolt length option. Let's say 300. The distance is 300 and the pitch here is 5. So let's say I need a bolt of 50 mm. Okay, not 50, let's say I need a bolt of 100 mm, and if I just press OK, the size will be reduced, and all the dimension, all the radius and the chamfers and the thread length will still be remained same. So this is how the parametric design works. You can also change the type of the basically there are various parameters that you can do. So let's get started. So before that, before making any design in parametric, just note down in your notebook all the necessary parameters, that basic parameters that is necessary to change your entire design. For suppose that for a bolt, suppose that there is only two things that needs to be changed. The first thing is the length of the bolt, and the second is the size of the bolt, the M1, M2, M3, M4. Like so, this is basic two parameters, at least two parameters needs to be made to make the parametric bolt design in Fusion 360. And also that if I just show you my parameters, I have also used the pitch and the pitch size and the coil section size, the thread size and the pitch of the thread, and the height of the thread can also be a parameter. So this is just to show you the basics of the design. So what I'm going to do, again I will be making a bolt here. So just go to new design, and before making anything, what I'm going to do is go to modify. I'm going to go to change parameters here. Now I'm going to tell Fusion 360 that I will be making some parameters, so I'm just going to make them here. So first parameter is going to be bolt. Suppose that the dia of the bolt, so bolt dia, this is going to be our bolt dia, and unit would be mm, and expression, let's suppose that for now I need M10 bolt, so just make in M10 and press OK. So we have a bolt dia of M10 here. Now again, now bolt length, bolt length. So let's say, what about 100 mm? We are going to make a bolt of M10 and the length is going to be 100 mm. So these are the two parameters. Now I'm going to show you how to use this parameter. Then I will eventually be inputting all the extra parameters there. For example, the size of the head, the height of the head, the thread and all, for example. So what I'm going to do is go to create a sketch and click on create a sketch. Now press C for circle, make a circle like this. Press D again for dimension and give this a dimension. Now remember what I told you, that the parameter I inputted the Fusion 360 in the input panel that I'm going to make a bolt of M10. So I'm not going to make the dimension 10. Instead, I am going to say bolt, select B. So it will automatically pick up the parameters. So bolt dia, this is going to be a bolt dia, and press OK. So you can see this fx here represents the function. So M10, the 10 dia is the function of the parameter. That's what we have created here. So anything that might change here, for example, let's make it 15. The circle will automatically be turned into 15. So let's make it 10 again and press OK. Now finish the sketch. Now I'm going to extrude it like this, and distance again is going to be bolt length. Press B and select the bolt length, or you can just type it BOLT, bolt length, and it will automatically get the FX sign. So you have a 100 mm length. Now the next thing is the bolt dia, sorry, the head. So what I'm going to do is, again, first of all, basically, if you are familiar with the parametric design, all the parameters needs to be made in one step, or otherwise it makes the process a little lengthy. So I am going to make the head size, and for the head size, what I'm going to do is, basically the head size depends upon the bolt size. Remember, the M10 and M15 bolt will not have the same size. So head size is linked to the bolt dia, right? So what I'm going to do is, again, I have assumed all the dimension. There is nothing is standard, nothing standard system has been followed. This is up to show you that is the tips and trick. So what I'm going to do is, I'm going to tell Fusion 360 that the head size is going to be, is going to be linked with the bolt dia. Suppose that the 10 mm bolt dia, the 10 mm bolt will have a different head size, and a 20 mm bolt will have a different size, right? So I'm going to link this the size of the head with respect to the bolt dia. So I'm going to say Fusion 360. If I just click B here, so this is the bolt dia, and star represent multiplication. So what I'm going to tell Fusion 360 that head size is going to be bolt dia, whatever the bolt dia will enter there, multiplied by, let's say it could be any dimension, let's say 1.5. okay, let's say 1.5, and press OK. So you can see that current the bolt dia is 10 mm, and the head size is bolt dia multiplied by 1.5, that is the value is 15 mm. Okay, now again click on the head size. Now the head thickness again will depend on the parameter. So what I'm going to do, I will link the head size to the head thickness to the head size. So for example, the head size is, let's say, 15. So I'm going to make it head size multiplied by, let's say, make it divide by 1.5 and press OK. So if I change the bolt dia to the 10 mm dia will have the bolt size of 15 mm and the thickness would be 10 mm. So just press OK for now. Go to create a sketch and sketch a head here. Now I'm going to go to polygon, go to transcribed polygon, and from there draw a polygon like this. Now press D for dimension, select this dimension and click here as head. Remember what we have written there, this is going to be head size, and press OK, and you may finish the sketch. So we have a head here. Now click on extrude, and extrude distance is going to be head thickness. So if I just click on head, this is the head thickness, and press OK, it will automatically be generated. Okay, the head is looking quite a bit smaller, so I am going to change the parameter. So just go to modify, go to change parameter. I am again telling that all the dimension has been assumed. So the head thickness, the head size is bolt dia multiplied by 1.5. So let's make it 2. and press OK. Now the head is, let's make it 1 equal to head size and press OK. Okay, I need to decrease the size, so just go to modify. The head thickness is going to be the head size divided by 2, like this, and press OK. Okay, this seems fine, although it's not an not good looking. I am just making it on a hit and trial basis. I don't have any particular dimension. No, I don't have any written dimension with me. Okay, let's make it 1.5. Okay, 1.5 seems too informal. How about 1.8? Yeah, 1.8 seems okay. So again, this is just to show you the tricks. Now let us assume that we have a bolt here. Now you can just give the fillet also. So remember, you can also select the fillet like this also. So let's leave the fillet for now. Now I'm going to make the threading. Now you can make the thread by making an helix and making the triangle profile and making a sweep, but that will take too long. So I'm going to the shortest method. What I'm going to do to make the thread, I will show you. I will be making a coil here. Suppose that I will be making a coil like this, and let's say the height would be 150. So if I just make it like here, make the revolution as 15, so you can see that it will cut you. And if I just select the section as triangular, it will cut the profile just like a thread. If I just press OK, you can see that it's a thread. Basically you can alter the pitch. So what I'm going to do, I will be making a coil to make the thread. So for altering the thread profile, like the pitch, the height and the thickness of the teeth, we will be altering the inputs that will be altering the coil size. That will eventually be altering our output as a thread. So what I'm going to do is, let's say if I just go to coil and edit the sketch, what coil I will be making is I will be making the height and pitch. So what Fusion 360 asks us, the first thing is dia. So you just have to note down all the parameters that is necessary. So dia, the first is dia. The dia of the coil will be equal to the dia of the bolt. The second thing is the height of the coil. The fourth thing is the pitch, and the last thing is going to be thickness. Angle, you don't need to be angling. That's so pitch, height, section size and dia. So just cancel it for now and delete this coil for now. Go to modify, go to parameters, and again click on user pattern. Now remember, write thread size. Thread size is going to be equal to our bolt dia. So whatever bolt dia we will enter, the thread will automatically be adjusted. Okay, thread size is linked to the bolt dia. Now again click on again. Now thread length. Now here if you want whole bolt to be threaded, you can make it equal to the bolt length. And if you want a particular length to be covered by the thread, not the entire bolt, so you can just make any expression here. So let's make it, let's say I will make it 20. Okay, let's make it 50 for now. You can also if you want the whole bolt to be threaded, you can make the expression equal to bolt length by, if I just click on bolt length, so you can see the thread length will be equal to the bolt length. But for now let's make it 50 and press OK. Now we have the thread size, the thread length, and the next thing is going to be pitch. Thread pitch. So this again can be linked with any dimension that you have created. For now let's go for 1.5 mm pitch and press OK. And the last thing that needs to be made is the section size, because again I have told you that I will be creating the thread with the use of the coil command. So section size is necessary. Again, if you are manually making it a thread, you can change the parameters accordingly. So let's make it thread section size, and this is going to be, let's say for now, 1, and press OK. Now we have all the necessary dimension that is going to be needed. Now press cancel. Okay, so go to create, go to coil, select this face, because we will start by making the thread here. Now select this face, and from center draw any dimension like this, and start by giving the dia as thread dia, th. We have thread size, so thread size fx represent that it is going to be representing, so just move it like here. Now go to height and pitch. Now the height is going to be, remember when I will be making the thread in this side, represent all the dimension, like here you can see that all the dimension has been made in negative, because we are doing the work on right side of the work plane. So eventually you just have to put that negative sign here before the thread. Okay, my system is getting hanged. Okay, the Fusion 360 was not responding, so just I just restarted my system. So just go to create, go to coil, from here make a coil like this. Remember, if I just drag it like this side and just reduce the section size to 1, you can see that we are working on the negative side. The height is in the negative. So what I'm going to do is, I will be making the dia as thread size. So this is going to be our thread size, and just okay, again make the section size as 1. Okay, so make it height and pitch type. So this is going to be thread size. This is thread size. The height is going to be thread length. So this is going to be thread length, and remember it's in positive, so we are working on the right side of the work plane, so every dimension needs to be negative. So I just press minus here, so we have a thread on this side, and this is going to be pitch. Remember, pitch is also in negative, so the pitch is going to be negative, and thread we have pitch, thread pitch here. So thread pitch is 1.5, as you guys can see. And the section size here is, if I just press thread section size and press OK. Now what it has done, it has created a thread like this here. Now as you guys can see, the thread seems to be a bit smaller. So what I'm going to do is, I will go to surface again, go to modify and go to parameters. Now we have all the necessary parameters here. So for that we need to change bolt dia, length size, and these are the main our parameters. So I'm going to click on star. So this is my favorite, and this is again bolt dia is my favorite. The pitch needs to be changed, the thread length needs to be changed, and the dia needs to be changed. So now let's make the section size. The one is looking too smaller, so make it 2, and if I just press OK, you can see that thread has been changed. So let's 2 be OK, and for the thread length let's make it 80, and if I just press OK, you can see the thread has been increased to 80 mm. Now let's see, what if I change the bolt dia from M10 to M20. So let's make it M20 and press enter. Now you can see the bolt dia has been increased, and with respect to that the pitch and the thread length and all has been changed. So you can just increase or decrease the thread length. Let's make it the thread, suppose that I want it to be 40, and the pitch can be controlled from here, and the bolt length, let's make it smaller. So now what if I just make it 50 mm and press OK? So this will decrease the bolt size. So what we have created a parametric design that will that is just based on these 5 parameters, and irrespective of that, there's these 2 basic parameters, and these 2 can be linked with some different dimension. Again, for now, let's suppose that you can give the fillet here also. So just make a fillet here. Let's make it 2 mm. So if you think that 2 is smaller, you can link the fillet. So you can just link this fillet with the dia. And for that, if I just go to modify, and if I just go to unsaved parameters, drag it, you can say that this is the model parameter. So here's the fillet. So here is the fillet, the D2 radius and the tangency. So what I'm going to do is this fillet I will tell the Fusion 360 that this is going to be represent on the bolt length. So you can just choose the fillet here also, and if not, you can again click on user pattern, new user pattern anytime, and you can just make the parameter of the fillet just like we did with the other dimension with link to another one. So for now, let's make a last modification. Just go to check, just show you the bolt length. I will be making a 200 mm bolt of, let's say, M25, and press OK. Or I need a thread length of 150 mm and press enter. Okay, so now the thread, as you guys can see, the 25 mm bolt will require a higher pitch. So let's change the pitch to 2.25 and press OK. So the pitch will be changed to 2.25, and the section size, as you guys can see, thread are more thicker. So let's make it, let's say 2.5. How about 2.5, and wait for the system to respond. Okay, 2.5 seems good. How about 3 mm? Let's make it 3. Okay, yeah, 3 seems fine, and I'll just press OK. So this is how you make design in parametric workspace in Fusion 360. So hope you guys will enjoy the video. This parametric design has unlimited use. You can make complex designs, any designs, and especially the catalogs that you see in SolidWorks or any CATIA, and the inbuilt catalogs that they have, like softwares like SolidWorks and CATIA, they have inbuilt catalogs that you can find thousands of bolts and screws that they make using this same trick. So that's why you just have to give the they ask you about the thread length and the type, and the software will automatically generate the design according to the parametric that parameter design that have been created with it. So hope you guys will enjoy. Do find if any queries or if I miss something, please don't hesitate to comment in the section below. So hope you guys will enjoy. Don't forget to share and subscribe. Thank you and have a nice day.